In this short video, we're going to look at factoring the GCF, factoring out the GCF. Factoring out the GCF is the golden rule of factoring. You have to do it in every factoring problem first. Look for the GCF in any factoring problem and do so. These problems that I have up here, they're just going to be factor out GCF and we're done kind of things. It's getting us used to always looking for that GCF. Some later videos we'll have problems where we'll factor out GCF and have to factor further yet. But the deal is, if you want to factor something completely or make sure it even factors at all, in some cases you have to take out that GCF first. So I call it the golden rule, super important. Always do this. Someone says factor this, look for this first. Greatest common factor, we would say GCF to keep it short. So the deal is, it's like we're undoing the distributive property when we look at this. And like one of the earlier videos I mentioned, well, what is factoring? Factoring is just the reverse of multiplication, right? So if we look at, like, say the number 15, two factors of 15 are 5 times 3, or 5 and 3. So a numeric example. And then the multiplied version would be 15. So we'll look at, or the product. So we'll look at problems like this right now, and what we're doing is we're going to try and write this as two things multiplied, two polynomials multiplied. So the directions on all of these problems that you're going to see are going to say factor completely. And so when we look at this and try and factor these things completely, the first thing I have to do, I look at the terms and I identify what the GCF is. Now the GCF is the greatest common, keyword common, factor of all the terms. The greatest common factor of all of these, if I look at just the numbers for now, this is 2 times 4, 2 times 2, 2 times 1. 2 is the greatest common factor. I'm going to take that 2 out. I'm going to use the blue color. All right, and then for the x, there's 2 x's here, or x squared. There's 1x, there's 1x. The greatest common, though, they all have at least 1, so I can take an x out. 1y, 2 y's, y squared, 1y. They all have at least 1y, so I can take a y out. Now you'd say times what's left. So now to fill in that polynomial, the factor that's left, I'm going to look at this and go, okay, well, what times this gives me exactly this? Well, if I look at the number, 2 times 4 is going to give me 8. So if I multiplied those, I'd end up back at 8. I took an x out, so x times what is going to give me exactly x squared? Another x. I only took one x out, I'm left with 1x. I took the y out, y times 1, or just y is y, so I took the y out. No need to write it in this term. My sign I'm going to fill in here, and repeat that. 2 times what gives me 4? 2. I took the x out, it's gone. There's only one x in it. I took one y out, but there was 2 y's, or y squared multiplied together, so I'm going to put 1 y in, fill my sign in. Now in this one you'll notice the whole term, 2xy, is actually pulled out. Common mistake, and why I picked this problem to make sure you look for this, because you'll see it in the book a lot. Yeah, common mistake is, oh, I factored it out, it's gone, and then they'll just, people will finish and they'll write the parenthesis right there. Don't do that, because you're going to be completely missing a term. If you were to remultiply and you didn't have anything there, you'd be missing a term completely, and it wouldn't be the factored version of this. So if everything comes out, well, you took the 2, the x, and the y out. Well, when you look back, 1 times this will give you that. So you have to make sure, or negative 1 times this will give you negative 2xy. So make sure you put the 1 in that case. Super important, so watch for that. Now this polynomial, I'm always going to get in the habit of looking at this and going, okay, this is a factor now. This is just going to be a tag along. It's part of the factored, completely factored problem. But does this thing factor further? In this case, it does not, because different variables, not an x squared, is not a polynomial that we would factor. So this would be my answer. The next example that I put up here, this is example 1, I guess, but I just put up 2 that kind of summarizes all of the types that you really see. All these videos are going to be short like that, so you don't have to sit here and listen to me talk for a long time, but they're quick and to the point, and I think they'll be really helpful even when you look at problems that are a little different, but with a similar approach. So on something like this, when I look at this, it looks quite a bit different, because I actually have like a common binomial, not just a variable, but it's actually a binomial or two-term polynomial that is common between these two separated by a minus. That's okay, it doesn't matter what it is. If it's common, you can factor it out. So if I'm looking at this separately from this, is like, say, that thinking of this as like almost like one term and this is like one term, I can actually take out the x plus 3 in the same way that if it was a variable like a y or whatever, I could take it out because they're both common. It's the greatest common factor. And this is an important thing because you're going to be doing this in the second stage on all the 4-term problems. If it's factorable and you look at a 4-term problem, the second stage you're going to end up with a binomial that's the same, so you're going to take this thing out. So the deal is, treat it just like you did with those. I'm going to go, okay, x plus 3, I'm taking that x plus 3 out, times what's left. And so when you factor out the x plus 3 out of this one, this times what gave you x times x plus 3? Well, I'm missing the x. When you take the x plus 3 out of this one, well, x plus 3 times what gave you negative 2 times x plus 3? It was the negative 2. And that's it. You'll be doing that a lot. If you look at 4-term ones, that'll be like the second step in the 4-term factoring problems. The next video, we'll look at 3-term problems where a is 1, and we'll continue going that way.